Adam Bakir. I'm a solutions architect here at AWS, and today I'm going to be taking you through, using a few AWS services and tools, how to build a serverless authenticated API for your mobile or web application. Now, if you've got any questions during the presentation, feel free to use the questions tab, and one of our moderators will help out as best we can. If any questions are unanswered, we'll send through a frequently asked questions sheet with answers after the webinar. Also, the material in this presentation, including a recording, frequently asked questions, and a copy of the presentation deck, will be shared with you in a few days after the webinar. So, if we have time at the end of the webinar as well, we will have a bit of a Q&A session as well. So with that, let's kick on. So before we start, I want you to consider the traditional API development process. So imagine you've just been tasked with building out an API for an application that you or your company is developing. So let's assume you've sat down and designed the API structure. You've mapped out each of the endpoints representing your resources and all the methods and operations that you're going to support on each of these resources. And that's great, but now what? Now that you've done all the design work, you've got to go code that, and you need somewhere to host that API. Well, traditionally, you'd create a bunch of servers or virtual machines to house your API code, and this really presents you with your first challenge. How many servers do you actually need? At the start, you sort of expect, maybe to handle only a few hundred users, but predicting the number of users is hard. And you remember the last time one of your applications actually went from 80 to 8 on the App Store, causing a tremendous amount of load and a poor customer experience. So you might decide to get a few more extra servers just in case, and so you have that large upfront cost before you even know if your application is going to be successful or not. So, and a large number of servers and virtual machines to keep running and maintaining, and that's just for the front-end API. And you got to do the same for the back-end application logic. So imagine for a minute, though, being able to develop your API for your mobile or web app that scales automatically to meet your actual demand. You can start small and then automatically scale when your app goes from 80 to 8 on the App Store. Imagine developing on a platform that has a granular cost structure, so you only have to pay for what you use. So you can experiment and try out ideas quickly in your development phase. Imagine developing an API so you didn't have to manage those servers and operating system patch levels, leaving you more time as a developer to add value to your application and business. And then, imagine being able to securely authenticate that without having to build that infrastructure to support that. Kind of as an API developer, that kind of sounds like a bit of a utopia, right? Well, that's what we're going to go through today in today's webinar. We're going to talk about how you would build a secure authenticated API using a couple of AWS services. So we'll look at Amazon API Gateway, AWS Lambda, Amazon DynamoDB, and Amazon Cognito to create secure serverless authenticated API for your mobile or web application to consume. So we're going to learn how to build out our API on Amazon API Gateway, where we will define this structure, our API structure, and contract for our API consumers. We'll look at how API Gateway routes and integrates your requests to a backend service. In our case, for that backend service, our application logic will be defined using AWS Lambda. We'll map out each of the API Gateway calls to a bunch of serverless microservices that handle the logic of that particular call. Then we're going to take a look at Amazon DynamoDB as our application data store. So we're going to it's here that AWS Lambda will store the state of our application. And finally, we're going to create an Amazon Cognito user pool that we'll use to manage our application's users and securely authenticate them for our API. So let's take a high-level look at this fully managed API model. So this diagram here shows the standard flow of an API call in this architecture. We'll be going deeper into each of these components as the webinar progresses. So firstly, a request from your application, a mobile or web application, or for that matter, even another backend service. Depending on the API endpoint that the application is requesting, this request will be routed to a backend. Now, in this particular case, it's routed to AWS Lambda. And this is where our business logic for handling that request will be implemented. Now, we could also handle that logic on an EC2 instance or even another publicly accessible endpoint, but using a serverless architecture with Lambda gives us a number of advantages that we'll talk about later. And in this case, Lambda can then utilize other AWS resources, such as a database like DynamoDB, to fulfill that request. So let's take a closer look at that API gateway in this architecture. So when a request is made to the API gateway, what's actually happening behind the scenes is that the request is first routed through one of our CloudFront POP locations. So CloudFront, for those you don't know, is a content delivery network offered by AWS that allows you to distribute content with low latency, a high data transfer rate, by serving requests using a number of network edge locations close to your users. So this ensures that your API gateway is offering a low latency for your users. When the API gateway receives the request, and if you've configured it to do so, it checks to see if the credentials inside that request is authenticated with Amazon Cognito. Now, once that user has been authenticated, API Gateway then checks for records for this request in its dedicated cache. If no cache records are available, it will then forward the request to the backend for processing. Again, the backend can be a Lambda function, a web service running on Amazon EC2, or any other publicly accessible web service. Once the backend has processed the request, the API call metrics are logged in Amazon CloudWatch, and the content is returned to the client. So we're going to apply that architecture to a very simple note-taking application in this webinar. And we're going to create an API to support it. Now, this note-taking application, I've called it a fictitious note-taking.io. It's going to allow an authenticated user to create, read, update, and delete notes, your typical CRUD operations. These operations will be handled by a Lambda microservice. And we will store the notes that the Lambda function creates in a DynamoDB table. Once the API has been set up and we can successfully read and write notes and verify that they're actually stored in DynamoDB, we're going to go about and add authentication to our application with Amazon Cognito user pools. So that's the app that we're going to build. Let's take a look at our first building block, the Amazon API Gateway. Amazon API Gateway allows you to define and host your API in AWS. So your API, that's your contract with your developers, right, for your particular application. To help manage this contract, we have the ability to sort of run multiple versions of an API. You can create stages. So these enable developers to deploy multiple stages for each version of your API. For example, a dev stage or a prod stage or a beta stage. And using the API Gateway, you can leverage the network that AWS has built. So AWS API Gateway leverages Amazon CloudFront to create a global distribution for your APIs. So again, this lowers the latency for your end users, but also gives your APIs DDoS protection out of the box to protect against things like malicious requests at layer 7 or lower level attacks, for example, SYN floods and the like. The API Gateway allows developers to throttle incoming requests and use CloudWatch to monitor the status and latency of your APIs and set alarms to respond accordingly. With built-in integration to AWS authentication services like Amazon Cognito, you can control access and authorization to your APIs. But before we dive deep into our API and on API Gateway for our note-taking application, we need to talk a little bit about the concept of a web-based RESTful API. So Amazon API Gateway allows you to define RESTful-based API. Now, the term REST, short for representational state transfer, was coined by Roy Fielding in his 2000 PhD paper, Architectural Styles and the Designing of Network-Based Software Architectures. And when we say an API is RESTful, we say it's RESTful if it exhibits some behaviors detailed in Fielding's paper, where the use of an API progresses an application by selecting resources and performing operations against them to initiate state transitions. Now that's a bit of a mouthful and it sounds pretty complicated, but it's actually really simple. A resource in a RESTful API defines the things or objects against which we will perform operations. So they are usually the nouns in your application. For example, in our API, we're going to be working with notes, creating, reading, updating, and deleting notes. So in this case, we could represent the collections of notes with a URI, or Universal Resource Identifier. For example, the URI http notetaker.io/notes. An API call there would represent a collection of notes, so the entire collection. The URI notetaker.io/notes/15 would represent a particular element in that collection. So we could perform operations on either the collection, creating new elements, for example, or operations on the element itself, maybe deleting a particular element in that node. In this case here, if we call a delete on /note/15, we delete the note with the ID of 15. Now, we perform those operations using HTTP methods. And you can think of these as the verbs or operations against those resources. Now, we use HTTP methods all the time. When we visit a web page, you're actually performing a GET operation against a URL. Now, in a RESTful API, we could use a HTTP GET to represent a read operation, for example. We could represent a POST method against either a collection or an element to create something. So, for example, if you call the POST on the collection resource here, this should create another resource. So, calling POST against notetaker/notes would create another note, for example. If we called, say, a delete HTTP method against an element in a collection, for example, a delete method against notetaker.io/notes/15, that would delete the note with the ID of 15. So, now that we've got some theory under our belt, let's take a look at the actual API gateway interface and how we can actually implement some of these. So here's a screenshot of the Amazon API Gateway console. Now, we're going to be looking at this in a demonstration of our NoteTaker app a bit later on, but let's go through this first. Now, on the left-hand side, we see the resources that have been defined in our API and the methods supported for each resource. So we've defined two resources, a /notes that represents the collection of notes, and a /notes/note ID that represents an individual element. The /notes resource represents an entire collection of notes, and it has three methods defined: a GET, an options, and a POST method. The GET method against the /notes will allow us to get all notes in the collection. If someone makes a request with a POST method against the /notes, this will create a new note in the collection. And then finally, our options method, we can use this to figure out what methods are actually supported on that resource, on that URI. And in this case, it will return GET and POST are allowed on this resource. Underneath that, we've got a /notes/note ID resource. And this is again used to represent an individual element in the notes collection. You can think of node ID here as a variable. So if the user calls this API with /notes/15, node ID will be 15 in this request. You'll also notice that a number of operations have been defined for note/node ID. Here we've got a GET, a delete, an options, and a put. So again, a GET would read an individual note in this case, a put will update an individual note, and a delete will delete an individual note. So that sort of defines our overall structure of the contract for our API. It defines our resources and the methods against those resources. Now, in this particular screenshot, we've got the post method selected. And the post method, with that selected, on the right-hand side, you see 4 big boxes. You've got method request, integration request, method response, and integration response. And this shows how a request, when it's made to the post method, flows through the API gateway. A request first arrives at the method request, then flows through to the integration request to the backend service, in this case here, a Lambda function called Notes Manager, then to the integration response, and then finally to the method response. Now, one way you can think about this screen is to think that everything on the left side of the orange line that I'm showing there defines the contract between your API and your developers. The resources and methods on the far left define the overall API structure. On the right of the line, sorry, I've just got a message there saying that the mic is a bit okay. Can you guys hear me okay there? I'll just try one. Okay, so on the right of the line, you can define how the request can be transformed and integrated to our backend service. Now, in the figure shown here, we are passing the request to a Lambda function called Notes Manager. A request will first be sent to the method request section. Here, you will perform your authentication. So as a request comes in this particular case, we've got no authentication set for this method. But it's here we can also define the model of our expected data input. So for example here, for this request, for a post, if we expect the body of the request to hold a field, maybe the name field or something like that, you could define that in your method request model. So models are defined using JSON schema, and we'll look at an example of one when we get to the demo. Once the request passes through the method request and has been authenticated and the data received is mapped onto the method request model, it passes to the integration request. Now, this section allows you to manipulate the data of the request before you send it to the backend system. So in this case, the Lambda function. Now, you could use this to perform transformation on that request. Maybe your Lambda function is expecting a different format than what you've defined in your method request, the model in your method request. So you could use this to change that data, transform that data to something that your backend system expects without actually affecting your API contract. So that request is then sent to the Lambda function, and the Lambda function will then return some sort of output. And it's here in the integration response that we can handle transformation of the data back from that Lambda function. So we could again, transform that information that comes back from our Lambda handler again at the integration response step. And then finally, we've got the method request response box. And this box allows you to define the expected model of your output. So what the contract, when you make a request, what it looks like, what the developer should expect back. Now, let's dive a little bit deeper. Let's have a look at what how that would work with the Lambda Notes Manager there. So we've got the notes post integrated with a Lambda function that creates a note. We've got the /notes_get integrated with a Lambda function that reads all the notes from the database. And we've got a put, which does an update, and a delete, which does a deletion on an individual node. So we've defined individual microservices in Lambda to handle those particular requests. And we're going to go through that in a little bit more detail. But data will progress through the method requests, through the integration requests, before it arrives at that Lambda handler. Now, let's say that our Lambda function expects a format that looks something like that. You've got an operation, we're going to create something, we've got a payload, we're going to add this particular note, and then we've got a table of the notes that we're going to write to. Now, we probably don't want to expose that data to our front-end API. It's a lot of implementation details, things like the table name and the operation. We want a model that just is simple. It just has a note and a note ID that you can refer to later. So we need some way of transforming that request body expectation that we've defined in our model to the Lambda request body. And it's here that we can use integration request mapping templates. So in the integration request, in this step, we can define a mapping template that maps the note and the note ID here to the Lambda body. So you can see here from the input, we're actually grabbing those two fields and putting it into a structure that looks like that before we hand it over to the Lambda request body. Now, mapping templates are a powerful tool and allow you to perform really complex manipulation of the data you receive from your client before you integrate it to the backend. And this increases your ability to integrate to multiple backend systems. They include functions for iterating through your responses and utilities to pass through the responses. You can learn more about mapping templates in our docs. So now that we've covered a little bit about API Gateway, let's take a look more closely at our second building block of our application, AWS Lambda. So again, here, it's where we'll define the business logic of our notes application. So one of the biggest benefits of moving towards a serverless architecture is that it allows you to focus on defining your business logic of your application and dramatically reduce that undifferentiated heavy lifting that you traditionally had to do, managing your servers, patching, that kind of thing. So AWS Lambda allows you to define stateless, trigger-based microservices that define your business logic. There's no infrastructure to manage. You upload your code, and Lambda handles everything else. With Lambda, you only pay for when your code is running. You're not paying for idle time. Lambda allows you to bring your own code. So there are a number of languages that you could use to define that business logic, and we'll go through that in a sec. And you can still use your threads, your processes. You can still access files just like you would normally. So at this time, you can write your Lambda functions in Node.js, JavaScript, Java, and Python. So you have access to all your native libraries that these languages support, and you can use third-party libraries or even roll your own. The Lambda context has the AWS SDK built in, so you can programmatically integrate with other AWS services. You have access to processes, threads, and sockets that you normally have running on a physical server or EC2 instance. The resource model is simple. So you pick the amount of memory that your function requires, and the CPU and the network are allocated proportionally. So you need more memory, you can allocate that with a simple request via the API or console, and the CPU and network will automatically be chosen for you based on this. Now, each Lambda function is considered stateless. In order to persist the data, you can use Amazon DynamoDB, S3, or Elasticache. In our case, for our application, our note-taking application, we're going to use DynamoDB. There's no actual ability to log into the box. These Lambda functions, they're transient functions that are spun up in response to an event. Now, Lambda can respond to an event in the entire AWS ecosystem of products. So, and you can even send events so that other Lambda functions can respond. So this allows you to build a serverless ecosystem on top of AWS. Lambda here acts as the glue between these services. So, for example, you put something in an S3 bucket, you can have Lambda fire when it sees something in that bucket. So Lambda allows you to securely grant access to resources inside the VPCs using AWS Identity and Access Management. So this allows you to fine-grain control over who or what can call your Lambda functions. Monitoring and logging are built into AWS Lambda, so you can use this data to collect metrics on requests, errors, latency, and throttles. And logging for each of the functions can be accessed using the built-in integration with CloudWatch logs. So here's a screenshot of the AWS Lambda Console. So you can use the console to edit your code in line or upload a zip file of the code that you developed on your local machine. So it allows you to configure test events and so forth that you can use to test your Lambda code. Now, Lambda comes in with a bunch of built-in integrations to a number of AWS services, including DynamoDB that we'll be using today, S3, Cognito, and API Gateway. There are also a lot more that we'll be using, SNS, Mobile SDK, and Kinesis included. So now that we've learned a little bit about Amazon API Gateway and AWS Lambda, let's take a look at a demo of building out our API for our note-taking application. So remember this API is going to take in notes, transform the data of the notes, and send it to a Lambda function to store in DynamoDB. So I'm going to switch to my browser here, and you can see there I've got a couple of tabs open in my browser. So in this demonstration, I'm going to start bottom up. I'm going to build out my DynamoDB database first to store the notes. Then I'm going to create a Lambda function that will be able to read, write, update, and delete that Lambda function, and then take a look at the API gateway so we can put an API in front of it. So you can see here I've created a notes table, and this notes table has two keys. I've got a primary key of user ID and a sort key of note ID. Now I want to be able to write notes in there such that my user ID may be Arden, a note ID of 1, and then whatever note I want to store inside there. So it's a very simple NoSQL database. And I need some way, and I'll just click refresh there to make sure that there's nothing currently in that database. But I need some way of reading and writing to that database. And this is where Lambda comes in. So I'm going to go up the top here and click on the Lambda management button here. And this is the Lambda page. Now, I'm going to create a Lambda function to handle writing to this database. And in this case, I actually don't have to write any code to do that. There is a blueprint. If I type in simple here, there's a blueprint called the simple mobile backend, and this this blueprint already has the code to read, write, update, and delete entries in a DynamoDB table. So we're going to use that. I would then go and select that one there, but what we're going to do is I'm going to click on the Lambda management, another tab here, and here's one I created earlier. So this is the Lambda function that is using that blueprint, the simple mobile backend blueprint, and we've called this Notes Manager. And for those of you who are Node.js or JavaScript fans, where you've got the code there that you can edit, but all this really needs is a couple of items to be able to read and write to that database. I'm going to click on Actions here and then click on Configure Test Event. And here I've got the actual operation that this particular function supports. So for example, I've got an operation called create. So this Lambda function expects an operation, and here you can create, read, update, or delete. You've got the payload, and this is the item that I want to create in this table. And in this case here, the table name is called notes. So I can go ahead and I'm going to test that. And this Lambda function, it's executing currently, should write to that table. So let's go over to DynamoDB, and I'm just going to refresh the table here. And you can see there I've been able to write to that DynamoDB database there without writing a single line of code. All right, so now that we've got some way of putting something into that database, let's put an API in front of it. So I'll go to my API Gateway console, and here is my notes service that we've defined. So here I've got a /notes resource and a /node ID resource with those methods that we talked about earlier in our presentation. I can create new resources by clicking on Actions and creating either a method or a new resource underneath that. Now the post method has been selected. If I go ahead and click on the method request here, that's the first thing that will the request will pass through. Now in this case we've got no authorization set, so this method is not authenticated. We'll look at that a bit later on. But if I go down to the request model, you can see I've got a model there that defines what I'm expecting as input. Now if I go ahead and click on models and look at that create model, here we've got the JSON schema that represents the data that I'm expecting in. So I'm expecting a name, a node ID, and a note in the body of my request. I'm going to click back on resources there, and I'm going to flow through. After the method request comes the integration request. So the integration request here, we're pointing to a Lambda function that we defined earlier, and I've got my body mapping templates, and it's here that I can define the transformation. So in this case here, we're going to take the name, the node ID field, and put it in a structure that looks like this. So I've now defined my API, and again, I have not had to write in much code other than a mapping template. Let's test this out. So if I go down the bottom here to an application called Postman, this is a cool little tool that allows me to create requests to the API and test my API. It's a plugin for Chrome in this case. I've got my method selected, post, and the URL that I'm going to be posting to. And the key bit there is the notes URL. And this is down the bottom here, I've got the body, and in this case here, I want to add a second note via the API called my second unauthenticated note, and I can set things like a header. So in this case here, I'm setting my content type. So if I send that request, what I'd expect to happen is it's going to hit that API. You can see down the bottom, the note's been created. It's going to go through that method request, which is going to match my model. It's going to go through the integration request, which will transform the data to something that Lambda expects, and then Lambda is going to go ahead and write that to the database. So let's check on that. I'm going to go back to Chrome. I'm going to click on my DynamoDB tab at the top here, and I'm going to refresh this table, and you can see there that the second note has been updated. So you can see there very simply, I've got a working API that I can read and write to with very little minimal code there that I had to write myself. So now that we have our API set up, let's take a look at how we would add authentication. So we're going to be using Amazon Cognito to implement authentication on our API. There are 3 authentication options that we can use with Amazon Cognito, and we're going to be looking at all of them. So you can use signature version 4, a Lambda custom authorizer, and the one that we're going to implement in our application, add to that API that we just created, Cognito user pools. So the first option when performing authentication with Amazon Cognito is to utilize signature version 4 or SigV4. You can use SigV4 and IAM policies, or identity and access management policies, to control authentication. So signature version 4, this is an Amazon process to add authentication information to each of those requests. So in the diagram below, we're going to have Amazon API Gateway. It's going to require that every request that you send be signed with a SigV4. So to sign the request, you calculate a digital signature using a cryptographic hash function, and the input to that hash will include the text of your request and your secret access key. The hashing function will return a hash value that you can then include in your authorization header in the API request. Now, the Amazon SDK includes tools that you can calculate, that allows you to calculate a SigV4 automatically. Now, the diagram here shows a mobile application being authenticated with Amazon Cognito. Now, in this case, Amazon Cognito is used to generate temporary credentials that can be used to authenticate with the Amazon API Gateway. Amazon Cognito first verifies that identity with an external identity provider, such as Facebook, Google, Twitter, or OpenID. Once the external identity provider verifies a user, Amazon Cognito will return a set of temporary credentials to the application. In this case, the mobile application will use these temporary credentials to calculate the SigV4. So that SigV4 credentials is then included in the authorization header before sending the request to Amazon API Gateway. So these credentials are used by API Gateway to authenticate the request and can be passed through to Lambda as well. The second option that we're going to look at to authenticate using Cognito is using a custom Lambda authorizer. Now, in this scenario, you create a Lambda function, and again, you can create this in the Java, JavaScript, or Python that Lambda supports, and its job is to authenticate that incoming request. So it's going to accept a set of credentials, usually via the authorization header, authenticate those credentials, and then return an IAM policy. Now, it can authenticate that to an external provider or even an internal identity source if you've already got one. It'll return an IAM policy, and this policy will contain the authentication and authorization policy for the credentials sent to the custom authorizer. Now, these policies are cached for a configured TTL, and API Gateway will only invoke your Lambda function the first time it sees a token. All calls that follow during the TTL period are authorized by the API Gateway using the cached policy. So they're the two options, but they rely on an external provider to provide identity. In our note-taking application, we want to store our own users. We want to have a database of users that we can authenticate against, and this is where Amazon Cognito user pools comes in. So our note-taking application, we need to store a list of users and the notes for each of those users, right? And I don't know about you, but managing user directories is pretty hard as a developer, and it's usually a responsibility that, as a developer, you don't really want. You don't want to worry about security, managing passwords, multi-factor authentication, user verification, password resets. The list goes on. So this is a perfect candidate to move to the cloud. In this case, as AWS will perform that undifferentiated heavy lifting, and you can focus on your app. So Cognito User Pools allows you to create and maintain a user directory and add sign up and sign in to your application. In this case, we'll use it to add sign up and sign in to our note-taking application. Now, user pools scale to hundreds of millions of users and are designed to provide simple, secure, and low-cost options for you as a developer. So you can use user pools to add user registration, sign-in features to your app, instead of using an external identity provider such as Facebook, Google, or Twitter. You can use user pools to host those users yourself. So there are a number of different scenarios that are designed to work with Cognito user pools. So these are all pretty common scenarios when managing users in a web or a mobile app. So Cognito User Pools handles user sign-in, and sign-in where a user can sign up to your application using an email, a phone number, a username and password. User Pools will authenticate them using these credentials. It supports email and phone number verification during the sign-up process to help verify the information given to your application is correct. If your users forget their password, Cognito User Pools provides flows to actually handle this for you as well. It allows you to store with the profile custom attributes for each of your users. So you could store things like maybe particular to your application, even a high score or something like that. If enabled, users can complete multi-factor authentication via SMS as part of the sign-in and forgot password flows. Along with user-based scenarios, there are a number of administrator scenarios that are also handled for you with Cognito User Pools. So it allows you to create, configure, and delete multiple user pools in your AWS accounts. You can have more than one, and you can manage individual users in that pool. You could create a user, you could configure each user's email, phone verification, set up password policies, including manually forcing a password reset. You can even define custom attributes to store things for your applications here as well. Along with that, you can actually set up custom Lambda triggers that trigger when different workflows. So for example, when you sign up, you might have a Lambda trigger that goes and adds it to another database somewhere, for example. So let's take a look at that authentication flow in a little bit more detail for user pools. So the first step that will happen is a sign up occurs. So a user signs up for an account with Amazon Cognito User Pools. It's not branded. It's you can make it branded to your particular application. In this scenario, the sign up process will ask for an email, telephone number, and password, in addition to any custom attributes that we've set up. Amazon Cognito will then automatically verify the user's email address by sending an email with a code to confirm or verify a phone number if you're using a phone number. So by sending an SMS code when they sign up via a phone number. Once the user has been registered and confirmed, they log into their application using the Amazon Cognito SDK. So the SDK will take their credentials and securely pass that across to Amazon Cognito user pools for authentication. If multi-factor authentication is turned on, Amazon Cognito user pools will send an SMS or email with a one-time authentication code. So after the user has been authenticated, the Amazon Cognito will return a JWT token. So this token is an OpenID compliant token containing the credentials and the claim for the user for this particular application. Now the JSON Web Token, or JWT or JOT, it's a base 64 encoded cryptographically verifiable claim. So the token itself is divided up into three sections. We've got a header, which states the algorithm and token type. We've got a payload, which contains your claim, and then finally a signature that you can use to verify whether the token has been manipulated or not. And you can use tools like JWT.io to show the decoded web token. And that's what I'm showing here. We've got in this particular case, we've got a Cognito identity token being showed. You can see that here. For a user, Paul Maddox, with a phone number that's been verified. And I've got some custom attributes here. I've got a purchase premium that's related to my particular application in this case. So the API gateway, once you've got that JWT token back from Amazon Cognito, your application will insert that in the authorization header of the request. So for example here, we're running a get method on /notes, so we want to get all the notes. And we've put our JWT token that we've got back from the Amazon Cognito user pools in the authorization field. Now API gateway will get that, and depending on how it's configured, in this case it's configured to directly use the user pool instead of a custom authorizer, to go off and validate that with user pools. If you're using a custom authorizer, that's where that would fit in. That's a step there that would fit in between that and the Cognito user pools to go off and do something. Now, if the authentication is successful, so Cognito user pool says, yep, that's a valid token, the API gateway will then pass your call to the backend function. In this case, our Lambda Notes function that will handle that request. Now, this authentication will be cached for up to an hour. So let's take a look at how we would add that to our application, to our note-taking application. So we've got a working API. Let's put authentication with Amazon Cognito user pools onto it. So I'm going to switch back to my browser. And I've already got the user pools tab opened up here. And you can see here I've got a couple of different user pools in my account. And I've created a note service user pool. So I'm going to select that there. Now, there is you could create your own user pool just by running through the wizard. This user pool currently has one user, that's me in there at the moment, with a required attribute of email. So you must have an email address. I've got some password policies set up, and I can manage my pool using this interface. Let's take a look at the actual users that have been set up here. So I'm going to click on the Users tab, and you can see here I've got one user. I've got myself, Pakir A at Amazon.com, and this is currently enabled and it's been confirmed. So the sign-up process has gone through, and the email has been verified, or email or phone number. If I click on that particular user, I can do things like send a request to reset his password. I can enable multi-factor authentication, or I can disable this user. I'm going to disable that user, and I'm going to delete that user, because we're going to create that user using the Amazon SDK. So here on another tab here, I've got a very, very simple user sign-up page. Now, this code will be released after the webinar completes. But here I've got some code that I want to register a user, confirm a user, log in a user, and get a token that I can use with the API gateway. Obviously you'd turn this into a nicely designed app, but just for the purpose of this demonstration, this will do. So the first thing I'm going to do is I'm going to register myself. password very carefully. And what that does do, it's going to use the API and the SDK to create a user in Cognito, user pools. So if I go into user pools now, and if I refresh this, what I expect to see is that user has now been in my pool, but it's in an unconfirmed status. So I'm just going to open my email here. I should receive a confirmation code. Now, I could easily go in here and manually confirm the user, but I should receive in a second. I'm just checking my email, and I've now got a verification code that I can use to verify and confirm this user. So this is used as an application to confirm a user's email address, and the code I got over email is that one. So I'm going to click confirm there, and again that's come up as confirmed. So that's going to hit our the APIs. If I go back to users and I click refresh here, I should see that change to confirmed. So I've now got a valid user in my user pool. So I should be able to log in. So I'm going to Amazon.com and I'm going to log in. And using the Amazon SDK, it's gone over to user pools and it's logged in because that's a confirmed user. And using the SDK, I can get a JWT token that represents myself as a user. So you'd use this behind the scene. I've just got a little button here that displays it so you guys can see it clearly. Now, if I copy that, I've got a little plugin for Chrome from JWT. If I paste that into this encoded section here, you can see there it's verified me, the payload here. I've got my email, some custom Cognito attributes inside there that I can see inside that JWT token. Now, there are many different libraries that you can use, and that come with most programmers have a JWT library that you can use to manipulate that token. Now that we've got a little web page sort of set up to do authentication, I've got a token. Let's set up our API gateway to use that token to authenticate that API. So I'm going to go over here and click on API gateway, and I've got another API that I've set up. It's exactly the same as the previous one, but with one key difference. In the method request, I've got a note service authentication added. So the steps to get there, if I click on the left-hand side there, if I click on authorizers, it's here that you would set up an authorizer. So you could create a custom Lambda-based authorizer or a Cognito user pool where the integration is done already. And that's what I've done here. So I've created an API authorizer called Note Service, where I've pointed to my Cognito user pools that I created before. Now I could grab that token ID and I could paste it in here, and fingers crossed to the demo gods, that should authenticate that claim that happened there. So I've got a token that I can then use. Now I'm going to click back on resources here, click on post, and you can see there it's been selected. So for this API, I should be able to do the exact same request that I did before, but this time I'm going to have an authorization header that I received from Cognito that I can use to authenticate me. So I'm going to go back to Postman that we used earlier. And you can see here I've got a similar request going to the /notes. So I want to create a new user, but this time I've got a header that includes an authorization field. My body down the bottom here, I've got the note, note 3, and a note of my third authenticated note. Now I don't have a name there that I had before because I've set up my function to retrieve that from the JWT token itself. In the headers field, let's insert that authorization, the token that I received, in the authorization header. So I'm going to paste that there, and I'm going to try execute that. So if all thing goes well, that's going to go through, hit the method request, authorize that, then hit the integration request, do the transformation off to the Lambda function, and then into DynamoDB. So let's go off to DynamoDB and check if that note, that third note, got sent in there. So I'm going to go back to DynamoDB here, and I'm going to refresh that table. And you can see here, I've now got an API, an authenticated note via my API. And again, it was just configuration without writing any code there for that. Just to prove that it works, let's go back to Postman here. And I'm going to just fake out this authorization by just writing gibberish inside there, make a send request to that, and I should get a unauthorized message. So you can see there, we've just, in the time of this webinar, we've set up a authenticated API. So, and this brings us to our fourth building block that we're going to use here. We're going to take a look at, now that we've got our API, how can we, that SDK that I used to build out that little web application, let's take a look at that in a little bit more detail. Now, the API gateway can automatically generate a client SDK based on your customer's API definition. So, that API definition that we did with nodes and the model and so forth, we can generate an API, for iOS, for JavaScript, for Android, automatically using the console. Now, this dramatically speeds up your development effort. So to use this, we go into the SDK generation field in the API console. We've generated API SDK management. Now that generated SDK, that's model aware. So if you've defined your model like we have, it'll automatically marshal and unmarshal requests to objects in the language that you've chosen. So dealing with model objects becomes pretty easy. It also includes methods for signing API calls and generating the AWS signature version 4, SigV4 headers in your API request. The SDK also features the ability to automatically handle things like throttling responses with exponential backups and things like that will add to the resiliency of your API client. So that brings us to the end of our developing authenticated APIs on AWS. So what have we learned? Well, we've learned how to define an API using a serverless architecture, and we've learned how to define the structure and how that flows through our API. We've integrated it with AWS Lambda for our little microservices. We've learned how to use Cognito user pools as a secure identity provider to authenticate that API. And we've also taken a look at some of the automated tools and SDK that the API gateway provides to automate some of these workflows. Now, there's lots of great examples on the AWS Labs GitHub account, so I encourage you to go check out the https github.com/AWS Labs for more information. So with that, I'd like to thank you for your time. We've got a couple of minutes left. So I'm just going to open up the questions tab here, and let's see if we can answer some of your questions. Or if you've got any more, feel free to raise some. So let's have a look here. Things about the audio. I've got a question from Lambda, from Gustavo Compas here, asking why doesn't Lambda support RDS? Lambda does support RDS, it just didn't fit it into that the slide pack there. With Lambda, you can integrate to Aurora, to Redshift, you can integrate to RDS Postgres. Yeah, so if you can call those external endpoints to do that. Let's have a look. Got another question there from Leonid Vanna. Can you use a custom URL for the endpoint? Yes, you can. So when we generated the URL for our API, that URL was generated for us. We can create a CNAME entry or something like that via DNS to point, or an alias record to point to that API gateway endpoint. Let's have a look. What else have I got? Okay. Yeah, so questions on what Lambda will support. We're looking at what languages Lambda will support. We currently support JavaScript, Java and Python, and we're always looking at developing new languages to support. I'd encourage you to work with either your solution architect like me or your account manager to try and raise that request. So at Amazon, more than 90% of our features come from requests from our customers. I think that's about it. So Joe, do you have anything else to go through there? All right, well, thank you for your time, guys. I hope you enjoyed today's webinar. Let's get building those authenticated serverless APIs on AWS. Thank you.